Assalamualaikum warahmatullahi wabarakatuh. My name is Nilai Putri bin Mahan, CE20232. For the assignment, I will do the task 1. So, the task 1, students are required to do the calculation using a nodal analysis and mesh analysis for the circuit given in figure 1. For nodal analysis, students are required to find all node voltage for the circuit, and for mesh analysis, students are required to find all mesh current for the circuit. For the solution for task 1, we use the nodal analysis at node A and get 13V1 minus 7V2 equal to A. Then we use the nodal analysis at node B and get 11V2 minus 7V1 equal to 64. Then after we compose of the equation, we need to find V1 and V2. Then we use the Cramer's rule. Then we know that V1 is equal to 5.7 volt and V2 is equal to 9.4 volt. Next, for mesh analysis, we need to find all mesh current. So for loop 1, we can get I1 equal to 2A based on the circuit. Then for loop 2, we need to use Kirchhoff current law and we get the equation 9I2 minus 2I1 minus 4I4 minus 3I3 equal to 0. Then for loop 3, we get I3 equal to negative 4M from the circuit. And lastly, for loop 4, we need to use Kirchhoff current law again and get 7I4 minus 4.7I4 minus 4I2 equal to 4. Then we need to insert equation 3 and 1 into equation 2 and get 9I2 minus 4I4 equal to negative 8. Then we use the Cramer's rule and get all the current value, which is I1 equal to 2M, I2 equal to negative 0.9M, I3 negative 4M, and I4 0.085M. Then I will pass to next presenter for the task 2 and task 3.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azlan bin Ruslan. My metric number is CE1H0011. Today I will present about the task 2 for the electric circuit 1. Okay. In this task, our group conduct an experiment by using any computer simulation tools available, for example, AutoCAD, PSpice, Multisim Electronic, Workbench, or Quartet Design Suite to prove the result in task 1. So, before we run the task 2, we need to do the circuit. Okay. Okay, this is the circuit simulation that we will build in the Multisim. Okay, and then this is the result for the task 1. Okay, let's see the simulation first. Okay, this is the circuit simulation that we built based on the circuit at the task 1. Okay, this is the V1, V2, I1, I2, I3, and I4. Okay, first, to get the V1 and V2, we use the calculation method, nodal analysis, and then to get the mesh, we use to get the I1, I2, I3, and I4, we use the calculation from the mesh. Okay, to get this value, we click the circuit and then we run. Go to simulate, analyze, and simulation. Okay, and then we run. Okay, as you can see, this is the value that we get from the circuit simulation at the Multisim software. Okay, for the I1, we get the 2 ampere. For the I2, we get the negative 0.9. Okay, 0.9, and then for the I3, we get the negative 4, and then for the I4, we get the 0.805. We should convert the milliampere, this one and this one, to the ampere. And then for the V1, we still get the same result like the manual calculation. Okay, for the V1 we get the 5.7 and V2 we get the 9.4. So this simulation value is always same like the manual calculation. So that's all for me.
Assalamualaikum warahmatullahi wabarakatuh, and hello to everyone. My name is Naomi binti Adam and my matrix number is AE180055. So today I would like to present the task theory, which is for the manual calculation and the simulation. So task 3, what we need is consider the circuit in figure 2. Find V0 by simplifying the circuit using source transformation to a single mesh circuit, so that you need to write only one KVL equation to find V0 given I equal to 2.5 ammeter. So this is the circuit. Next is how we solve in the manual calculation. So first we need to do the 6 resistor is parallel to 3 resistor, and then it's series to 10 ohm. Next we do the source transformation, and from the source transformation we could get the voltage. So we could get the voltage for 32 volt and the 36 volt. Next we combine back the circuit. So when we combine we could get like this, and then we can simplify the voltage. So 32 minus 8, so we could get the 24 volt. And for the resistor we could do the simplify also as the series 16 ohm plus 20 ohms, which is we could get the 36 ohm. And then next we calculate also, and we find the current, so we could get the 2/3 ammeter. So next we solve this one first. So next we do the source transformation back, and then we could get the voltage as 6 volt, and then we combine, and this is our last final loop, which is we have the 6 volt, 9 ohm, 36 volt, 12 ohm, 7 ohm, and the V0. So this is, we can do the mesh analysis. So this is 1 KVL. So by using the mesh analysis we could get the equation like this: 6 volt minus 9I plus 36 volt minus 12I minus 7I and plus V0. So at here we could get the KVL. So when we simplify we could get the negative 28I plus V0 equal to negative 42, and I will be replaced as 2.5, and then from that we could get the V0 as 28 volt. So next is the circuit simulation on multistate. I would like to continue our simulation, and this is the simulation for task 3 on the multisim. So at here we run it. After we finalize the circuit, we get the V0 as 28. So next I will proceed to the Proteus. So we are back with our simulation task 3 on the Proteus. So at here we could get the 6 volt and 9 ohm, 36 volt, 12 ohm and 7 ohm. So this is the voltmeter. So what we need to do, we could run it. When we run it, we could get the 28 volts. So after we're done with the simulation, so we will discuss the result and analysis on manual calculation and simulation. So for the manual calculation, we could get the 28 volt as shown in this table, and the simulation on multisim we get the 28 volt also. With the simulation on Proteus also we could get the 28 volt. So as we can see from the result on manual calculation and simulation, the value of V0 is same, which is 28 volt. Thus our simulation and calculation is proven. So that's all from us. Thank you.
So for the conclusion, from the assignment, we have successfully conduct a simulation by using a suitable simulation tools. Electric circuit fundamental, especially nodal analysis and mesh analysis theorem, were successfully understood comprehensively. We were also able to learn to work in our group efficiently and perform presentation effectively. Furthermore, we can also remind of our previous lesson and use our knowledge from the previous studies in this assignment. That's all from us. Thank you.